In the last few units, we've been looking at image data, which is a common data set for machine learning to process. But now we're going to turn to a new type of data called time series data. And this is also very common, and a lot of data falls under this. So this is generally any data that's collected at regular time intervals, and we often record when the data was recorded, and what we record. So, for example, maybe you're just taking your daily temperature outside at noon every day. So you record the date where you go out and collect the temperature, and then the temperature you're recording. So this would be a time series, a series of data elements collected over a set of time frames for this. Now, generally, we collect these at a regular interval here, so maybe every 24 hours or something like that. Um, Sometimes there might be glitches or planned outages or stuff like that. For example, if you're looking at daily stock market data like closing price of stocks, the stock market doesn't run on Saturdays and Sundays, so you'll have Monday, Tuesday, Wednesday, Friday, and then you'll have 2 days of missing data and then start up again. And so sometimes we can ignore that. Sometimes we the data is there, we just don't collect it and stuff. So we'll talk a little bit about that. But our general assumption is that data is collected at regular intervals for this. Now, often you're not just recording one point of data, you're recording multiple ones. So maybe if you have a little weather station outside every day, you wouldn't just record the temperature, but you'd have the temperature, the wind speed, the relative humidity, things like that. So often we're looking at what we call multi-dimensional data. So like same with stocks, rather than just looking at one stock, often you're looking at a whole set of stocks, and you do those recordings at again specific times. So often record all the data at a certain time. So maybe closing on each day you record a stock price. So we have four different companies here, and that so every a row here is observations at a certain point in time, and every column here is different features or different things we're observing, and they each observation is at a different point in time for that. So that's kind of more standard is this multi-dimensional time series data that we'll be working with. So what kinds of data fall into this? So, there's a lot of data. Certainly, weather measurements, anything we're recording, temperature, humidity, that sort of stuff at a certain time. Financial markets, whether that's stock prices like we've seen, commodity prices, the price of oil or wheat, currency exchange rates, euro to dollar, that sort of stuff, cryptocurrency rates, interest rates, any sort of financial data generally varies and is recorded regularly over time. Similarly, at any company or any organization, you probably have monthly product sales reports or monthly expenses or weekly expenses or quarterly reports. At Scholastica, we keep track of the enrolled students every semester and have a history of that. Operations performed here at maybe at a hospital or clinic. This whole set of data sets on what operations and the outcomes were and how many were performed in a healthcare setting. So again, it depends on your organization, but they often have these sorts of data summarized on a weekly or monthly basis or something like that. So things you may not think of are things like music. So music is generally can be broken down possibly as a sequence of notes. There's a format called MIDI, M-I-D-I, which records the order the notes were playing, when the note was played, and when it was started and when it was ended there, and in what tone it was, and what that sort of stuff. There's also not just notational music notation, but actual the sounds themselves. You might digitize sounds and bring it into frequency. So just normal music is actually just a time series. It's just a sequence of frequencies broken down at every time. So frequency intensities at times. So digital music. I keep thinking from a CD, but just any sort of digital music is a sequence of sounds of frequencies played. Similarly, text is a sequence of letters. Now, this might not actually be assigned at a certain time, but it is ordered here. And so that can often fall into our same places. So certainly spoken words, what you're hearing now, it can again be thought of like kind of music, but as words. But just written letters are in an order, and so we have that order, and so we can talk about what sentence, and we can talk about the order of the letters or the order of the words. And the order matters, and that's one of the more important things. Is there is a lot of data out there that has maybe timestamps on it, but the time is not that important. So maybe like in Netflix, it's not that important uh, when you watched a movie, and but it's more important what you thought of the movie. So if you watched three movies over the last month, it's more important what those movies are and how you liked them. It doesn't really matter maybe how what order or what time of the day you watch those movies at from a Netflix point of view. But like in text or music, it's very important the order of the notes, the order of the words. If you swap the order of the words in a sentence, can change its meaning significantly here. So again, we're often looking for data that is ordered or has a time associated with it, and also then that timing is important. Just at a conference this weekend, the Mix conference, and one of the papers being presented was doing motion capture to try to identify exercise. So again, and we have a motion capture lab on campus at the physical therapy department that tracks gaits, especially irregular walking and standing gaits for people in therapy. And so again, we might be again we generally record the position of the different joints in the body over time at regular intervals for that. And again, any sensor data, traffic data, stellar intensities, SETI radio data, any sort of sensor out there is generally reporting out data at a regular interval. And it is often important that the order or the sequence of the data. If you're trying to do exoplanet identification, you're looking at star intensities, and you're looking for patterns in that star, and variability as that star intensity goes down, as maybe a planet transits in front of that star. So the order and of all those measurements are important. So okay, so once we have this time series data, what kind of tasks can we do with it? And again, this falls along kind of our old model of, well, we can do categorical, we can try to put it in categories, or we can do what we call regression, or prediction is more a common term now. We're getting into these time series stuff. So let's talk a little bit about categorical. So you might take like a set of tweets and try to classify them as they're racist or not, or reviews of music or products, and are these reviews positive or negative? You might be looking for abnormal signals. So like in the SETI, search for extraterrestrial intelligence, that sort of radio signals, they get a lot of signals that are just normal, and they're trying to identify the abnormal signals in that. We might take music and try to classify that into genres, or even take classical music and classify it into composers. So if you are shown or play, you hear a 10-second clip of a classical music item, can you identify that as a genre, by the composer who wrote it? Or similarly, pop music, can identify the artist or the genre it's in. And I mentioned again earlier about motion capture. What that paper was doing is actually try to classify the exercise types. So they were watching people or collecting these joint positions, and then saying this. They had 5 different types of exercise: sit up, squat, discus throw, and that sort of stuff. And they were saying, oh, I can analyze this time series of motion capture things and say it's this type of exercise. So that was a categorical stuff, and there's some of that. But again, I think the more common, well, I guess where the big money is in time series is if you can do prediction of time series. Often people are looking and wanting to pay you to predict time series. If you look at a sequence of values, can you predict the next value in this? And if you can predict the next one, can you predict the one after that and the one after that? So certain things like predicting markets or financial data. Just the normal forecasting the weather. Can you forecast the weather, the temperature for the next 7 days there? Now, in tech stuff, we'll actually look at more creative stuff like, can you predict the next word or letter you're typing there? We're seeing that autocomplete stuff. But then once you're able to do that, can you actually have neural network generate a poem or stuff like that? In one of our examples, we'll feed Alice in Wonderland into a network, train it on that, and see if it can generate a new stanza or a new paragraph for Alice in Wonderland there. And similarly, for generating music, here, can we do that? There's actually people who are now trying to write whole musicals by breaking a musical down into different components and then training neural networks to write and group create those different components and stuff like that. So now let's just talk about some challenges in time sequences. These are some common things we'll see that we often have to overcome. So the first one is seasonal forecasting. A lot of time series data is dependent on what I'm just calling seasonal stuff, but it's actually more regular fluctuations and predictable somewhat fluctuations here. So seasonal stuff, like if you're looking at wheat productions, if you're looking at house sales, if you're looking at sales of patio furniture, any of that sort of stuff will have regular fluctuations. Even flu cases in the United States will have these regular fluctuations based on the season. So they might go up in the summer and then down in the winter, or vice versa here. And it's not always seasonal, like the sunspot data follows an 11-year cycle. There's some stuff that follows the tidal cycle, so it'll change, but depending on the tides that are moving in. So there are different things, but anything has cyclical. There's some ways of doing this. This is kind of outside the scope of this class, but often what we want to do is kind of recognize this pattern, the overall pattern, and then take the pattern out of here, separate the pattern from the other data. So then we can look at the other data itself and then overlay it on top of the pattern for that. So there's different ways of doing that for things, and we're not going to do that. But one with times, I mean, with neural networks and these sorts of things, we often want to see if the network can learn these seasonal patterns also. And if that's the case, we have to make sure we give it enough data so it can see a pattern, not just see a small segment of this. And we'll talk more about that, what that means when we get to moving windows later on. So. Another thing is just trend forecasting. Sometimes this is challenging, where something is just always going up at a certain rate or down at a certain rate. So although it's fluctuating in there, there's a general trend of this. And again, often we'll try to find that trend, maybe do some linear regression to identify a trend line there. And then once we have that, we'll take that trend out of there and then predict this stuff. So sometimes, again, we're going to watch trend lines for this. Now, what is even more challenging is with these are both combined when we have some sort of seasonality to our data and also a trend line for this. So this is monthly airline passengers in thousands from 1950 to 1960. And so the number was increasing, and it's also very seasonal and has different blips here. It follows a set kind of pattern for ups and downs. So again, this is often requiring both things. So again, in traditional forecasting, you have to identify the trend and remove the trend from the data, identify the seasonality, and then try to remove the seasonality, and then predict from there, and then reintroduce the trend and the seasonality into the data. But with our neural networks, we'll just try to have the neural networks learn this and work on the predictions for this. Another challenge we have sometimes is discontiguous observations. We don't maybe have regular data all the time. And again, sometimes this doesn't cause problems, like in the financial markets. They might be closed on the weekends and stuff like that. And you can actually just look at the data without that data. It's not like the data is missing. It's just there isn't any data. The markets were closed there. So sometimes you can just ignore missing or irregular or discontinuous data. But often you do have to worry about that because, again, you're watching things at certain regular intervals, and these things are still happening. So, like one example, Kaggle had a challenge, I think it was this summer, that I was looking at. where they were again looking at suns and trying to identify exoplanets by looking at intensities of different stars. But the telescopes would point at a star and do readings, and it might take some readings for that day for that star for like 5 days, 5 nights in a row. But then there might be clouds, or it might move to a different area, and it might not come back to that star system for another 5 days. So that there was this irregularity of when the measurements were taken. It certainly wasn't nice and regular. So again, we sometimes have to watch and figure out how to handle this discontiguous data for that. Okay, so that's an overview of time series. Next video is going to jump into how we're going to process that with recurrent neural networks.